So we want to talk about the high order derivative. So we begin with this function f of x, which is equal to 3x cubed plus 10x squared minus 5x plus 2. Okay, so we take the derivative. Okay, we take the derivative, which is the df of dx, right? We write it. So it's equal to f prime. So if we take the derivative, we take the derivative for each term, right? The constant, we just leave the constant 3 times the derivative of x cubed, which is 3x squared plus 10 times x squared. The derivative would be 2x minus the derivative x equals 1, so it's minus 5 plus what? The derivative of 2 equals 0. So you will have 9x squared plus 20x minus 5. So this is the first derivative. So you can see that the first derivative is still a function of x, right? So we can continue to take the derivative. So we take the derivative. So this is called the first derivative. First derivative. So now let's continue to take the derivative of the first derivative. Take the derivative of first derivative. Okay, so this is the derivative of this function. So it's equal to what? Equal to 9 times the derivative of x squared, which is 2x, plus 20 times the derivative of x equals 1. Then minus the derivative of 5 equals 0, so it's 0. So this would be 18x plus 20. And this is called the second derivative, which is the derivative of the first derivative. So we denoted this one by f double prime of x. If we want to use Leibniz notation, it can be written as the d squared f over dx squared. So this is called the second order derivative. So of course we can continue, this is still a function about x, we can continue to take the derivative. We take the derivative of the second derivative, which is the derivative of 18x plus 20, so which is 18, right? So this is called the third derivative. Okay, we denote it by f triple prime of x. Or you can write as the d cube f over dx cube. So this is the third derivative. Now let's continue to differentiate. We can take the derivative for the third derivative, which is the derivative of 18, which is equal to 0, right? This is called the fourth derivative. And the fourth derivative is actually the derivative of the third derivative. So here we don't use the 4 primes. We write down the parentheses 4. So this would be the fourth derivative. It's not the fourth power because we have the parentheses. That means which is denote the order of the derivative. So this one would be d to the fourth f dx to the fourth. So this represents the fourth derivative. So in general, the nth derivative, okay, of this function, which is the derivative of the n minus 1th derivative, right? So here the fourth derivative is the derivative of the third derivative. The third derivative is the derivative of the second derivative. The second derivative is the derivative of the first derivative, and so on. Also, the nth derivative is the derivative of n minus 1th derivative. So we can denote this one as d to the nth over f dx to the nth. So this is the nth derivative. So here is some remarks. Okay, and the first one always has some conventions that if we write this way, so that means there is no derivative, so which is equal to f of x. Okay, the first derivative can also be written as this way, but in general we like to write it as a f prime. This is the first derivative, right? The same thing, the second derivative, which is f double prime. The third derivative is f triple prime. So after 3, we always use the number to denote the order of the derivative. Okay, so this is so here some another notations. So f, sometimes you will see f squared. So what does this mean? This means the f function f, then take the square for the whole function, right? And the double prime, which is the second derivative. Okay. So here is another fact that if suppose p is a polynomial, with degree n, so that means this is the an x to the n plus b a n minus 1. This is a polynomial, x to the n minus 1 plus a1 times x plus a sub 0. So this is a polynomial. So if you take the derivative for this function p, we take the case derivative. If the order k is greater than or equal to n plus 1, so in other words, greater than the order n with degree, greater than the degree, then the case derivative, if k is greater than the degree, then the case derivative must be 0. So you can see from our previous example. So you can see this function f is the degree with degree 3, right? If you take the fourth derivative, 4 is greater than 3, so you will have 0. After that, the fifth derivative will also be 0, right? And the sixth derivative is also 0. So after that, if the order greater than the degree, then you will have 0. So here is the application of the high order derivative, which is called acceleration. So we know that if s of t, which is the position function of the moving object, then the velocity, instantaneous velocity at time t, which is the derivative of this position function, which is denoted by ds dt. So this is the velocity. And the acceleration, so which is a of t, the acceleration is the rate of change to the velocity, right? Describe how the velocity change. So which is the rate of change of the velocity. So the acceleration is the rate of change is the derivative, right? Is the derivative of v. So since v is the derivative of s, so this acceleration is the second derivative of s. This is the acceleration. Okay. So here is an example. If you have a position function s of t, which represent a moving object, okay, on a straight line, which is 12t minus 4.9t squared. This is the position function. So what's the velocity? The velocity would be s prime, which is you take the derivative for each term, which is 12 minus 9.8 times t. Right? At a different time, you have the different velocity. What is the acceleration? Acceleration is the second derivative of s, which is actually the derivative of the velocity. So which it means the derivative of 12 minus 9.8t, so which is negative 9.8. So this is acceleration, which is a constant acceleration.